Hello everyone, welcome to CodeChef. Myself Jwala Chaurasia, and today we are going to solve the problem which came into starters 208. The name of the problem is alternate jumps and the problem code is ALJMP. The difficulty rating of the problem is cakewalk and the prerequisite is at top. Let's start with reading the problem statement over here. So guys, problem says there are n lily pads arranged in a line. They are numbered 1 to n from left to right. A frog is initially standing on lily pad n. The frog loves to jump, so it will perform a sequence of n minus 1 jumps with alternating direction as follows. First jump to the lily pad n minus 1 position to the left of its current position. Next jump to the lily pad n minus 2 position to the right of its current position. Next jump to the lily pad n minus 3 position to the left of its current position. More formally, in the ith jump, I lies from n1 to n minus 1. If I is odd, the frog will jump to the lily pad n minus I position to the left of its current position. That is, if its current position is x, its new position will be x minus of n minus I. If I is even, the frog will jump to the lily pad n minus I position to the right of its current position. That is, if its current position is x, its new position will be x plus n minus I. It can be proved that all of the frog's jump are valid. That is, it will always be on one of the lily pads 1 to n. You are given n. Can you find the number of the final lily pad that frog will end up at? Input format, the first line of input will contain a single integer t denoting the number of test cases. Each test case consists of a single line of input containing a single integer n. Output format, for each test case, output on a new line, the answer, the final position of the frog. Constraint for t lies from 1 to 100, for n lies from 2 to 100. So guys, now let's understand the sample test case in the question more precisely over. So guys, this question is pretty much straightforward. It shows the movement of a frog. So let's say a frog is standing on a lily pad n, okay? Yeah. The frog loves to jump, so it will perform n minus 1 jumps, okay, always. So first jump to the lily pad n minus 1, that is the last position to the left of its current position. And the next jump would be n minus 2 position, that is to the right of its current position. And next jump would be n minus 3 accordingly. So more formally, if they talk, the ith jump will be from I to n minus 1. So if I is odd, that is the index I is odd, the frog will jump to the lily pad n minus I position to the left of its current position. That is, if its current position is x, then the new position would be x minus n minus I, because that would be the left of its position, okay? Or let's say if I is even, okay, that is the index is even, the frog will jump to the lily pad n minus I position, that is to the right of its current position. That is, if its current position is x, the new position will be x plus n minus I, that is to the right of it, okay? So it can be proved that all the frog jumps are valid, and that is, it will always be on one of the lily pads 1 to n. So we are given n, we have to find the number of the final lily pad the frog will end up, basically the position which frog will end up. Okay, now let's take, we have got n as 2, okay? So there are two lily pads over here. So number 1 and 2. So the frog is on lily pad 2 initially. Okay. So the frog will be, there will be n minus 1, which is equal to 1 move made, right? So in which frog will jump one step to the left from 2 to 1, right? So hence he will end up at position 1, that is of lily pad 1, right? Now let's take another test case. Basically we have got 3, okay? So there are 3 lily pads, 1, 2, 3. Okay. Then the frog is on lily pad in its right 3, right? There will be n minus 1, which is equal to 2 jumps made. So the first jump would be at 2 positions left, right? Because n minus 2, it would be 3 minus 2, which is equals to 1 at the position 1, right? So second jump would be 1 position to the right. So 1 plus 1 by according to this formula, which will 2. The frog will end up at position 2 at the final. So guys, I think the test cases are pretty much clear. Simple simulation, guys. Now let's move toward the simple solution. Let's the frog's position be x, initially x equal to n. Now after the first move we have x equal to n minus 1, which is equals to 1. And after second move we have x equal to 1 plus n minus 2 equal to n minus 1, so on. So in general, it can be seen that every pair of consecutive moves, the frog will effectively move one step to the left. This is because it will jump left by some length, say d, and then jump right by one length less, so d minus 1. So if it was initially at x, it will end up x minus d plus d minus 1, which is equal to x minus 1. So if n minus 1 is even, we can pair up all adjacent moves, and each adjacent pair will result in decrease of 1. So the frog's position will decrease by exactly n minus 1 by 2, and so its final position is just n minus 1 by 2, which is equal to n plus 1 by 2. So if n minus 1 is odd, okay, then we can pair up the first n minus 2 moves, but the last moves will be left around. So the last move is an odd move. So it involves jumping left with a distance of 1. The n minus 2 paired moves decreases the position by 1 for an overall decrease of n minus 2 by 2. So the frog's final position would be n minus of n minus 2 minus of 1, which is equal to n by 2, right? So the answer would be is just n plus 1 by 2 if n is odd and n by 2 if n is even. Okay. And this is a simple simulation, guys. Simple observation, just to have to see how the frogs are moving. We get a formula. Now let's move towards the simple C++ code, guys. So guys, this is my simple C++ code. I took the input for all the test cases, and at the last, I'm simply printing my answer as n plus 1 by 2. And you can see that, guys, I have got my C++ code right now. Let's move toward the Python code. So guys, this is my similar Python code. I took the input for all the test cases as well as n. At the last, I'm simply printing n plus 1 by 2. That would be my position. Yeah. And as you can see that, guys, I have got my Python code right. So guys, I think the solution, the code and the approach is pretty much clear. Now let's meet in the next video. Thank you so much, guys, for watching our videos.